Hello friends, welcome to the fourth chapter of the lecture series. In this chapter, we will learn how to model, how to analyze, and how to design a 3D frame. So far, we have done a beam, which was in a single plane. After that, we did a 2D frame, which was in two planes. Now we are doing a 3D frame, which is in the three planes. As I've told you in the previous chapters, please make the configuration as per your requirement. For that, you have to go to the configuration, left click on the configuration, and from here, please choose the unit you want. Also, you can change the background color if you want it white or if you want it black. Similarly, you can change the STAAD default design codes, so you can change them later as well. So after making all the selections as per your choice, so click on accept. Now what we do, now let us open a new project. Click on new project option here. From here choose space, and the file name we give here as 3D, not hash, 3D frame practice. And from here choose the folder where you want to save this file. As I have suggested you, always make a different folder for a file. And here you can change the units of the length and also the units of the force. You can change these things later as well, but if you make selections here, it will be easier for you to start. After doing this much of work, click on next, and here choose add beam option, and after that click on finish. Now just close this window over here. We will not use this method to model our structure. We will define the nodes from here. Now let us see what kind of structure we want to model for this chapter. It's blank here, but I will draw a 3D frame. Let's begin. So first I will draw a column, and I'll provide a fixed support. All the supports here will be fixed. There won't be any hinge or the roller support. Let me draw the structure. This is a column, and I'll draw a beam. After that, I'll draw the column. Again, I'll provide the fixed support. And here, if I draw the axis, this is the X, this is Y, and this is Z. Here you can see that I have gone in the X, I have gone in the Y. Now what we'll do, we'll go in the Z as well. And again, let's draw the columns. And here also, let's draw the columns. It is a very simple structure. The span, let me take this span as 5 meters. You can take any span you want. You can take 6 meters, 7 meters. It's up to your choice. And this span I'll take as 4 meters. And this span over here I'll take as 3 meters. Let's do this span as 6 meters and this span as 4 meters. It will be a bit more clear. So I'll draw this as 6 and this as 4 meters. Here only we got columns and the frames. We will not have any slab over here because drawing and designing a slab is very complex in STAAD Pro, and while applying the load we don't need the slab at all. That is why we will not be modeling the slab in this structure as well as in the building. I will do a different chapter that will incorporate only the slab portion. Right now, the slab will be omitted. It will not make any difference to the design of our structural members. Now let us model this structure in STAAD Pro. So let us go to STAAD Pro. Okay, one thing that you need to understand is while choosing the origin of your structure, make sure that all the Z portion or the X portion is positive. It will be easier while you want to apply different loads at different parts of your structure. To make Z and X positive here, you have to choose your origin at this point because Z is positive in this direction. Okay, in this direction Z is positive. That is why this node will be in the positive direction. Similarly, X is positive in this direction. That is why this node will also be in the positive direction, which means this node will also be in the positive direction. In case of building also, for example, if this is the plan of your building, so origin we will choose here, somewhere here, so that all the portion is in the positive direction. That is why we choose the 0, 0 node at this point. So this is our first node. This is node number 1. And next node, what we will do, we will choose this node as the next node. The distance from this node to this node is 5 meters in the X direction. So let us go to STAAD Pro. The first node, let us choose at 0, 0 and hit enter. You can see you got a node here. Now what we do, we just copy this node so that we get our second node. To select this node, first select this node's cursor. So left click on it. Select this node by left clicking on it. Left click here. After that, press Ctrl plus C. And after that, press Ctrl plus V. Now it asks where you want to paste this node. By the following X, Y, and Z values, we are copying this node in the X direction that you can see over here. This direction is the X. In the X direction, we want to copy this node at 5 meters from this position, which means that we have to enter 5 meter here and it is in the positive direction. Click on OK. After that, you can see you got a node here at a distance of 5 meters. Also, the coordinates are automatically defined for that node. Now what we do, we just select these two nodes. For that, hold Control and select this node, and after that select this node by left clicking on it, and again hit Control plus C and hit Control plus V. Now what we are doing, we are copying these two nodes in this direction, that is in the Z direction, so that we can get a node for this position as well as this position. The distance from here to here is 6 meters. So what we do, we go to STAAD Pro and in the Z direction, that is the positive Z direction, we give 6 meters and hit OK. You can see that you got 1, 2, 3 and 4 nodes. Now again, what we do, we select all these 4 nodes. For that, you can individually select them, or what you can do, you can zoom out first, and after that just left click here, drag your mouse so that all your nodes are inside this rectangle, this selection rectangle. And once all the 4 nodes are inside the selection rectangle, release your left mouse button. You can see that all the 4 nodes are selected. Okay, now you can see that we have selected all the 4 nodes. What we are going to do, we are going to copy these 4 nodes in this floor as well. I'll call this as a floor. For that, what we do, we go to geometry. You can either use Ctrl C and Ctrl V option, but that will be a bit complex. So what we will do, we will go to geometry menu, and here you can see the option translational repeat. You just left click on it. You can find this option here as well, translational repeat. And here it asks in which direction you want to copy these nodes. we want to copy these nodes in the y direction. And here number of steps 1 means we want to copy these ones. Default step spacing, the spacing here is this 4 meters. Okay, spacing from here to here, that is 4 meters. Input 4. The important thing that you have to do is over here click on link steps. If you do this, then automatically the nodes will be copied and the column will be drawn. After that, click on OK. You can see that the nodes have been copied as well as the columns have been drawn. If these nodes were connected by the beams, then the beams would have also been drawn in this position as well. But we didn't draw any beams here. Now we have to draw the beams here manually. For that, select this option. Okay, before that, save. Select this option, add beams option here, and left click on this node over here. Left click, and after that, left click here. Left click on this node again, and left click here. Left click, left, here to here. Now you can see that you got a frame. If you want to see the dimensions of the beams and the columns, what you have to do? You have to go to this option, dimensions, left click on it, and click on display. You can see that the height is 4 meters, the width is 6 meters, the width in the z direction, and width in the x direction, that is the length, you can say, is 5 meters. Choose remove and click on remove. After that, click on close. Let me tell you that there are different other methods by which you could have drawn this frame. This is not the only method. You have to keep on practicing, and once we do the building, you will have known most of the methods, and you have to keep on practicing so that you can find your own method which you feel is the easiest one. Now moving on, let us go to the journal tab, and let us first define the beams and the columns. For that, let us go to the property option over here. Left click on the property that is already here. Okay, all right, now let us define the beams and the columns. Click on define, and we will be defining the rectangular beams and the columns. You can define the circular columns if you want. Let us go to the rectangle option, and let us define the beam first. I'll choose the lower values this time so that we can get the prominent shear force and the bending moment diagrams. The depth I'll choose as the 150 mm, that is 0.15 meters, and the width I'll choose as 100 mm or 0.1 meters. That is a very small size of beam, and click on add. After that, let us define the columns. The column I'll choose of 150 by 150. Yeah, that will be sufficient. And after that, click on add, and after that, click on close. Here we have defined the beam and we have defined the column. Now what we do, we assign the beam and column to our frame members. First, let us select the beams. You can either individually select these beams, or what you can do, you can go to select option over here. After that, go to beams. Okay, save it. Again, go to select option over here. After that, go to beams parallel to option, and you can see that the beams means actual beams. So here beams refers to beams and the columns both, but our beams are parallel to the x and the z direction. How? Because you can see that this is our x direction, this is x, and this is our z direction. And you can see that these four beams, these two beams are parallel to the x direction, and these two beams are parallel to the z direction. Similarly, if you have got multiple beams like 100 beams, all those beams will be parallel to the x and the z direction, and the columns will be parallel to the y direction. You can see the y direction is in this way, so these four columns will be parallel to the y direction. which means that to choose the beams, you have to select beams parallel to X and the Z direction, and to choose the columns, you have to select beams parallel to the Y direction. Let us go to STAAD Pro and let us go to select, and over here choose beams parallel to and click on X. After that, go to select again and go to beams parallel to again and click on Z. Here we have selected the beams. Okay, so I should have selected this option first. Now it will just go away. Okay, I'll select this. Oh, it has gone. I'll again go to select, go to beams parallel to X, again go to select, go to beams parallel to Z. You just do this, and here make sure that it is assigned to the selected beams option has been checked, and click on assign. After that, click on yes. You can see R1 means the rectangular section 1 has been assigned to the beams. After assigning the beams, now let us assign the columns. For that, select this option, rectangle 0.15 by 0.15. After that, go to select, go to beams parallel to, and after that, click on Y option. You can see that all the columns have been selected. If you had 1000 columns, all those 1000 columns would have been selected. Now what we do, we use this option assign to selected beams and click on assign. After that, click on yes. You can see the rectangular section 2 has been assigned to the columns. After assigning the sections, now let us assign the support. For that, first we have to define the support. So go to the support tab here and click on create option over here. After that, click on add. Here, as I've already told you, we got the fixed supports only. To assign the fixed support to our structure, first select the support. After that, we have to select the nodes where we want to assign this support. To select the nodes, go to the front view, that is view from +Z, and left click somewhere here and drag your mouse. Drag your mouse such that make sure that the node cursor selected here is the nodes cursor. Drag your mouse such that these two endpoints are inside the selection rectangle. After you reach here, release your left mouse button. You can see these two nodes are selected. To ensure that all the nodes have been selected, go to the isometric view. Here you can see that all the 4 nodes have been selected. Now what we do, we choose this option assign to the selected nodes, and after that click on assign, and after that click on yes. You can see the fixed support has been assigned to all the 4 nodes. After assigning the support, now what we do, we define the load and the load combination. So go to load and definition option available here. After that, click on load case details, left click on it and click on add. Choose primary option here. Load number is 1. Loading type, we are defining the dead load first, and the title is dead. You can name anything here, but it must represent a dead load type. Okay, and after that click on add. Similarly, we'll add the live load, LIVE, and the loading type is live. Click on add. For now, in this example also, we will use the dead and the live load only. In building, we will use dead, live, and seismic load. Click on close. Now let us define the loads inside the dead load. Click on dead option here, and after that click on add. Okay, save it. Click on add. First load that we assign is the self weight. Direction is Y and the factor is -1. Click on add, and after that next load that we give is, okay, let me show you. Let us assume that all these beams, this 1, 2, 3 and 4, these all 4 beams have got a wall. This is our wall, okay, and let us assume that the load due to this wall is a UDL. If this is a beam, is a UDL, and let us assume that the intensity of this load is 10 kilonewton per meter. While doing building, we will see how this load intensity can be calculated. For now, let us just assume this value. This is the dead load that we are going to apply. Let us apply 10 kilonewton per meter load in these two beams. These two beams will have 10 kilonewton per meter load, and in these two beams will have 5 kilonewton per meter load. Okay, now let us define accordingly. These loads are the member loads. So left click on the member load, and it is a uniform force. The force is minus 10 kilonewton per meter. D1, D2, D3, they all are 0 because we are applying the load in the entire span of the beam. The direction is GY, that is the global Y direction, and minus 10 means the downward direction. Click on add. You can see a load definition has appeared over here. Similarly, next load that we define is the 5 kilonewton per meter load, and click on add. We got two loads, 10 and the 5 kilonewton per meter. Okay, now let us define the live load that we are going to apply as well. Let us assume that this is our floor. Okay, this is our floor, and on this we are applying the live load of 2 kilonewton per meter. And let us also assume, okay, let us also assume that in this, so this is our live load, okay, 2 kilonewton per meter square. This is the intensity. And let us also assume that we got a floor finish of 1 kilonewton per meter square, and this is a dead load. Okay, here you have to see one thing. The Y range that this slab lies is, this is our 4 meter. This entire region is Y is equal to 4 meter region, which means that if I take the region from here, okay, let me change the color. If I take the region from here up to somewhere here, like 5 meters, so this is 1 meter above. If I take the region from here to here, my slab will lie within this region. Is it? Yes, it is. Or what you can do, you can take from like 2 meter, this is 2 meters somewhere here. If I take from 2 meter to 4 meter, my slab will still lie in this region. To give these kind of loads, you have to specify this region. Okay, let me first define this dead load. For that, again click on dead and click on add option. This load is a floor load, so save it, and the intensity is minus 1 kilonewton per meter square. Choose Y range option here, and here you have to define the range. Define Y range, minimum and the maximum, which means that in Y range, our Y range can be from 2 meter to 6 meters, 10 meters, 11, 12, any higher value you choose. We will only have this slab. We don't have any other slab. But suppose that if this is our building, okay, this is the ground, and we got first floor at 4 meters, we got a second floor at 8 meters, we got third floor at 12 meters. In this case, for applying the load in the first floor, the Y range should be any value from 0 to 4. That is, I can take 1, I can take 2, I can take 3. So 3, and any value that is equal to 4 or greater than 4 but must be less than 8, which means that I can choose 4. So Y range here is from 3 to 4, 3 meter to 4 meter. If I give Y range, then this floor will be selected. If I give 5, again only this floor will be selected because we don't have any floor here. If I give 6, again only this floor will be selected. If I give 7, again only this floor will be selected. And if I give 8, then this floor will also be selected because the Y range, this direction is Y, and this Y range value will cover this floor as well. So this is the concept of Y range, from where to where you want to apply the loads. So here our Y range should be, let us take minimum value as 2 meters and the maximum value as, you can use 4 meter as well. It will still select that slab. I'll take 5 just to be in the safer side, okay? And similarly, the concept of the X range also applies. Here we got only one slab. That is why we got a full X range, okay? We got a full X range. But suppose that we got 4 slabs, and this is 1 meter, this is 2 meter, this is 3 meters, okay? In this case, and in the Z direction, this is 1, this is 2, and this is 3. Let us just suppose. And suppose that you want to apply 2 kilonewton per meter square load in this portion only. In that case, the X range is 1 to 2, minimum value is 1, maximum value is 2, and the Z range is 1 to 2, minimum value is 1, maximum value is 2. And if you do that, only this portion or this panel will be selected. If you give the minimum value of the X range as 2 and the maximum value as 3, and for Y, if you give minimum value as 1 and maximum value as 2, which means that this panel will be selected. Only at this portion the load will be applied. This is the concept of the range. Here, as we don't have any range for the X range because we are applying in the entire slab, we will give the minimum and the maximum value as 0, and same goes for the Z range as well. We click on add, and here you can see that you don't have any question mark in this load value, which means that you don't have to separately apply this load. Once you define the range and give the intensity of the load will be automatically applied. Now just click on close. If you want to see this load, what you have to do, you have to just left click on it. You can see how the load has been transferred to the beams. The ultimate goal of defining the slab is to transfer the load on it to the beams, isn't it? The same thing is done by STAAD Pro without even defining the slabs. Due to this reason, we don't define the slabs because defining the slab is very complicated and it will take a lot of time. That is why we don't model the slabs in our regular building projects. You can see how the load has been transferred to the beams and how the load has been applied on the beams. Now let us go to the live load and define the live loads that we are applying here. So left click on the live and click on add, and we're applying the floor load. We will define the live load of -2 kN per meter square intensity. Direction is global Y. The distribution is not one way, it is a two-way distribution. The Y range is minimum Y range, let us give as 3, and the maximum Y range let us give as 4. Let us see what happens. Okay, and after that click on add, and this is the only live load that we are applying. So click on close, and if you left click on it, you can see the live load has been applied and the live load has been transferred to the beams as well. Now let us assign the beam loads. For that we have to select the beams. Okay, Let us go to, all right, say, let us go to the top view, that is view from plus Y, and we'll select these two beams. And once you select this beam, hit press Ctrl, and after that select on this beam. Here we will apply minus 10 kN per meter load and click on assign. So make sure that assign to the selected beam has been checked, and after that click on assign, and after that click on yes. Now you can see the question mark has disappeared, which means that we have applied the load. Now again let us assign the 5 kN per meter load. For that, select these two beams, okay, and after that click on this load and click on assign, and after that click on yes. We have to assign the self weight as well, so click on self weight, and here we will choose assign to view and click on assign, and after that click on yes. And let us see the isometric view. You can see that the wall load has also been applied. You can see the higher value at these two beams and the lower value at these two beams. After defining the loads, now let us define the load combination. For that, click on load case details, and after that click on add. Here we will define the load combination. As you can see that we have applied two kinds of load. Actually, yeah, two kinds of load, dead load and the live load. These two loads are not applied separately, one by one, okay? These two loads are applied simultaneously, and when we design our structure as per the limit state method, what we do, we multiply the loads with a partial factor of safety so that we increase the intensity of the load, and also we divide the strength by the partial factor of safety so that we can assume that our strength is low, which is actually not. Our strength is high, but we just assume during the calculation. So by increasing the load and by decreasing the strength, not actually decreasing, we get a greater window of safety. That is the limit state of method. While defining the load combination, we multiply the loads with a partial factor of safety and we apply those loads simultaneously. So here available loads, we got the dead, and we'll multiply this load with a factor of 1.5. Here type means how these loads will be added. We will choose normal option. Load combination, we'll name it as 1.5. This is, okay, let me give the bracket, dead load plus live load. In RCC design, we got 30 kind of load combinations as per IS 456-2000. We will define all those load combination when we design our building. Here we will define only one kind of load combination just to see how it works. After you select this load, dead load, and give the factor of 1.5, just click on this option. You can see load case 1 AI factor is 1.5. Save it. After that, click on live and give the factor as 1.5 and click on this option. So here it is, factor is 1.5 for both dead load and the live load. Click on add, and after that click on close. You can see the load combination has appeared over here. Click on close. Now what we do, we go to the analysis print option. Select no print option, or you can print anything that you want to see. Click on add. You can see that we have added the analysis command here. Click on close, and after that click on analyze and click on run analysis. So you have to save your structure. Here you can see that our structure doesn't have any error and also doesn't have any warnings. We will just stay in the modeling mode and click on done option. Now we have to give the design command to the STAAD Pro. For that, click on design tab, and after that select concrete option here. From here, select the code if it is not selected by default, and select the code that is followed in your country. Now let us select some parameters such as what is the compressive strength of the concrete, what is the grade of the rebars that is used. Let us select those parameters. You can see that a lot of parameters have already been selected, and we'll just unselect them by click on this option. Many of these parameters are useful, but here we will use only two parameters, that is FC, compressive strength of the concrete, and click on this option, go option. You can also give the clear cover as well, but I will not use this this time. I'll use this while we are doing the building. And also click on FI main, that is the yield strength of the main reinforcement. Click on this option, and also I'll use the FI sec, that is the yield strength of the shear reinforcement. And anything else that I need, not for now, and just click on OK. And now let us define these parameters and click on define parameters. FC that I'll be using is 20 MPa, that is M20 grade of concrete. The compressive strength of M20 grade of concrete is 20 Newton per mm square. If you convert it to kilonewton per meter square, it will be 20,000. Give this value and click on add. After that, click on FI main. Let us use yield strength 415, or you can use 500 or 550. I'll just use 415 for now. 415 Newton per mm square in kilonewton per meter square, extra 30. After that, click on add. Similarly, FI sec, I'll use 415.123, 415.123, and click on add. And after that, click on close. You can still see that a question mark is against the option that we just defined. This is because we have defined but not assigned. We will assign this in a while. Before that, let us give the commands to design the beams and the columns. For that, click on commands and click on design beam command and click on add. You can see the design beam command has been added. Similarly, click on design column and click on add. Design column command has been added, and click on quantity takeoff. It will give you the total quantity of the steel that will be used in this structure, and click on add and click on close. Okay, now select the entire structure. The grade for the entire structure is FC 2000. Okay, so select this. If you want to define columns of different grade and beams of different grade, then you have to define two FCs. Here I have used only one. You can define two FCs as per your requirement. And after that, click on assign. Okay, save it. Click on assign to the selected beams and click on yes. So FC has been selected, and also we'll assign the FI min to our entire structure. So select the entire structure and use this option assign to the selected beams and click on assign and click on yes. Similarly, FI sec 41500, select this entire structure and click on assign, and after that click on yes. And design beam option, and we have to select the beams only. So what we do, we go to select and go to beams parallel to x-axis, and again we go to select, go to beams parallel to the z-axis. We have selected all the beams. Now what we'll do, check this option, assign to selected beams option, and click on assign, which means that these 4 beams will be designed as per the formula of the beam, okay, as per the codal provisions of the beam, and click on yes. Now select design column and select all the 4 columns. Go to select, go to beams parallel to, and click on Y option. And after that, select assign to the selected beams option here and click on assign. And after that, click on yes. These 4 columns will be designed as per the formula or the codal provision of the column design. After doing this much of work, go to analyze and click on run analysis and save it. Now click on view output file and click on done. From here you can see other things that you already know. Now I'm interested in this results option, so click on results and click on concrete design. Here you can see all the inputs and the outputs. FC main, FI main, FE sec, design beam 5 to 8. So beam number 5, and if you click on this window and if you press shift plus B, you will get the beam numbers. Okay, so this beam is the beam number 5, which is over here, which is displayed over here. So you can see the design of beam number 5. The length is 6 meters, size is 100 by 150 mm, cover is 25 mm. Section fails while designing section, which means that this section has failed. And if you see the other sections as well, okay, go to results, concrete design. You can see that almost all of our sections have failed. This is because we defined small sections and applied huge loads. So no need to worry. What now we have to do is that we have to define new sections or edit the older ones. So what we'll do, we'll go to the geometry, and this is what we do when our sections fail. What we will do, we'll go to the general tab, and after that go to the property tab that we're already in, and click on this option, that is all these beams. Okay, and click on edit. The depth we'll use here is 0.40. Okay, 40 by 0.35. Let me use this section and click on change. Structure. As a result of this, post-processing results will no longer be available. Do you want to delete all the result files? Click on yes and click on close. Similarly, let us edit the columns as well. Click on edit and let us give the columns as 0.5 by 0.5. I'm just taking higher values so that I don't have to come here again and change the size. Click on change and click on close. Now again, let us go to analyze and click on run analysis. So let us save it. Zero errors and zero warnings. So zero error option is very important. If you got any error, you cannot go further. Let us select view output file option and click on done and click on results and click on concrete design. Now here you can see that beam number 5, length is 6 meters, size is 350 by 400, cover is 25 mm. So summary of the reinforcement has been given. Top reinforcement at 0 meter, which means that at the origin, this much value, and 1500 we don't want. At 3000 is 0 square mm, 45 0 square mm. So at the other end of the span it's 444.67 mm, which means that this beam has got reinforcement at the top, at the edge only. So we have to provide the extra bars. And the bottom reinforcement we got at the mid portion only. This is how you see the reinforcement values of the beams. While doing the building, we will see how you can detail these reinforcement bar into the number and the diameter of the bar. I'll show you how you can convert this reinforcement value into the diameter and the number of bar. Similarly, you got a reinforcement for the other beams as well. And if I keep on going down, we got a design of the column as well. Column number 1, design results. Okay, required steel area, required concrete area, and it has also detailed as well. Provide 12 dia bars. Though STAAD Pro can give you detailing also, however, I suggest you not to use the detailing given by the STAAD Pro, because detailing is not an easy task. You have to use your mind, you have to see the condition of the beam, the nearby beams, the columns, the floor height, everything. You have to check. On the basis of that, you have to detail your structural members. So detailing is not something that can be done by a program, not at least the programs that are developed currently. For detailing, you have to use your own engineering skills. And if I go down and down and down, you can see the total quantity of the steel that will be used in this building. That is 33770 kg of the steel. And the total volume of concrete is 7.10 cubic meter. This is how you can find the total quantity of concrete as well as the total quantity of the rebar. You can find the quantity of the individual rebar as well, but this is just for the approximation. Please use your own skills to get the quantity of steel in your structure. Let us close this. Now let us go to the post-processing option. After that, click on OK. Make sure that all the options are here and click on OK. Let us maximize this window. First, we will see the reaction values. For that, you can just click on reactions over here, or what you can do, you can go to results and click on view value, and from here click on reactions and what reactions you want. For the loads, I want global X and global Y, and for bending, I want global RZ, and click on annotate. You can see the reaction values in the X and Y direction and movement in the Z direction. Click on close. Again, go to results, click on view value and click on beam results. Let us see the displacement first. Click on maximum results and click on annotate. In order to annotate displacement, you must have displacement diagram on. Please switch on the displacement diagram. So we have to switch on the displacement diagram. Click on OK. For that, click on this option over here, deflection. Click here. You can see the maximum deflection in each beam and the column. And after that, select maximum results and click on annotate. Press Ctrl and scroll your middle mouse button in the clockwise direction. You can see the deflections. You can see the deflections in the beams and the columns. So this is a highly exaggerated view. Now let us see the bendings. For that, we have to first turn on the bending moment diagram option. To do this, click on MZ option that is available here. Left click on it. And after that, click on bending at maximum position. Okay. And uncheck this maximum results and click on annotate. Okay. And also unselect this option, deflection. You can see the maximum bending moment. Let us unsee these reactions. Go to reactions and just uncheck them and click on annotate. Okay, and again let us go to beam results and hold control or press control, and after that use middle mouse button to scale the movement values. You can see how the movement changes in the columns and how the movement changes in the beams. Let us see the front view. Okay, so this is much more similar like a 2D frame. You can see that the movement is maximum at the support and also at the beam column joint. It is the maximum value. That is why beam column joint is considered as a very critical zone. Okay, you can see how high the movement is at this position. Similarly, let us see the maximum shear force. So uncheck this and check this one and click on annotate. Okay, yeah, I have to turn on this one. FY. So press Control and increase middle mouse button use to see the shear force values. You can see the shear force values in the beams and the columns. So let us see the isometric view. You can see how the shear force is constant in the columns and how it changes in the beams. At this position, shear force is almost zero, and at the ends, the shear force is maximum. Due to this reason, we place the stirrups closer at the ends of the beam and farther at the mid position because the shear force is minimum. Now let us animate our structure. Click on animation and let us animate the deflection and click on OK. You can see the animated deflection of our structure. So this is how you model your 3D frame, apply the loads and design it. This much for this video. Hope it was helpful. Thank you for watching and take care.